Lawrence Livermore is starting to work with IBM in a partnership and collaboration to explore how the IBM True North neuromorphic chip is going to be able to be applied to problems in the national interest. Specifically, we are looking to see how we can tackle simulation modeling problems and pattern recognition, classification, inference problems across the national security space, but in particular in the fields that the ASC, or Advanced Simulation and Computing program, is tasked to explore and develop. The key innovations that make True North interesting are that it's very low power, it operates at speeds close to real time, it is a very large spatially distributed architecture, and it uses asynchronous communication techniques to allow the system to try and solve the problem in some ways at its own pace, very much the way the human brain does. As we push HPC architectures towards exascale, one of the main challenges we are facing is how much energy is consumed by the system when it's trying to run the computations we're interested in. Right now, we're applying many tools to help alleviate that. That's high-performance, well-designed traditional CPUs, bringing in GPUs, tightly coupling them with the CPUs, and non-volatile memory. The True North architecture is a fourth approach that we're going to integrate into HPC systems that will allow us to solve certain class of applications with much less energy required, and thus able to bring the entire system energy down. As we mature this technology and research into new ways to use this is going to allow us to add a new class of accelerator to these large HPC systems, fundamentally expanding their capability without dramatically increasing their power budget. True North is a new approach to computing architecture that will allow us to innovate in how we solve algorithms and also how we develop high-performance computing architectures. We're looking forward towards exascale, where we're going to see heterogeneous systems that include high-performance CPUs, GPUs, non-volatile memory, and hopefully neuromorphic chips such as True North. This is a really exciting development and mirrors what we've seen with the rise of graphics processing units, or GPUs, over the past decade as they've gone from gaming systems into scientific computing. With this collaboration with IBM and working with the True North architecture, we're looking to change how we fundamentally solve large-scale scientific computing and simulation problems, both in the interest of basic science and advancing the state-of-the-art, as well as solving critical problems in the mission space of national security.